Assalamu alaikum, my dear students. I hope all of you are fine and doing well. So, topic here we are going to discuss it is the oxidizing properties of the group 7A elements. Basically, the group 7A elements, these elements are called as halogens. As the word halo means is a salt, and the word gens mean forming. So, they are basically called as the salt forming elements. And the group 7A elements or the halogens includes fluorine, bromine, chlorine, and iodine. These all exist always in the diatomic form as F2Br2Cl2 and I2. This is their diatomic form. And among this, the fluorine and bromine, fluorine is present in the gas form, bromine is present in the liquid form, chlorine is also in the gaseous form, and iodine it is present in the solid form or the solid state. So all these halogens can work like as an oxidizing agent. Now, how do they work as an oxidizing agent? Let's have a look on this. Their oxidizing properties. All the free halogens they can act as an oxidizing agent while reacting with the metals and the non-metals. Now, all the reactants or the reactant elements that require positive oxidation state in the compounds these are formed. Likewise, if they are going to react with the metals, like metal here we have Na, which is sodium, while reacting with the chlorine it produces the compound which is NaCl. So here the positive part will come from the metals and the negative part will come from the chlorine, where the chlorine it is a non-metal. And the product here it is formed, it is sodium chloride, which is called as the simple salt. On the other hand, these metals they just lose the electrons. On the other hand, the non-metal which is chlorine or the halogen they can gain the electrons. And upon losing the electrons, that metal will be changes into the cation, and the Cl2 will be changes into the that is halogen anion by the gain of electron. And now the force of attraction will be created between this cation and anion, and the bond will be formed which is called as the ionic bond. This is a simple overview about these reactions. And if we talk about their oxidizing power of the halogens, then it just decreases down the group. The first one element is fluorine, then we have chlorine, bromine, and iodine. And their oxidizing power down the group it is going to be decreased. So we can also write it as fluorine, chlorine, bromine, and iodine. And there is a decreasing sign between their oxidizing power. So fluorine is having more oxidizing power as compared to the chlorine. Then chlorine is having more oxidizing power as to compared to bromine and iodine. Now here we have the formation of the simple ionic compounds with the metals. When metals are going to be react with the halogens, here the X2 just shows these are the halogens. And after the formation of these compound, there is a metal halogen or metal halogen bond, which is basically the formation of salt. Example is sodium chloride formation by the reaction of sodium and chlorine. Here we have another example like potassium, which is a metal on reacting with the chlorine. It just forms potassium chloride, now which the potassium is a metal and the chlorine it is a non-metal, and it forms a salt which is named as potassium chloride. And on the place of potassium we can also take another metal we can take magnesium, calcium, we can take sodium, we can take lithium. And on the place of halogen here, which is denoted as X, can be react with the chlorine, bromine, as well as with the iodine. Now, here we have some factors upon which the oxidizing power of the halogens just depend. Now, the first one factor is energy of dissociation. Means if there is a bond between two fluorine atoms, bond between two chlorine, bond between bromine, and bond between the iodine. Now, what amount of energy is required to break that bond? This energy is known as bond energy of dissociation or bond dissociation energy. Oxidizing power just depends upon that how much how much the stronger bond is between these two atoms. The second factor which affects it is the electron affinity of the atoms. Basically, the electron affinity is the amount of energy released when we just add up an electron. Here we want to add that an electron. As a result of this, the energy will be released. So that energy is called as the electron affinity. That how much affinity that atom just have for the added electron. This is called electron affinity energy. On the other hand, it depends upon the hydration energy of the ions. The hydration energy is a simple amount of energy. The word hydra means the water. When it is just added up in the water, what type of or what amount of energy is released is called hydration energies of the ions. The last one factor is heat of vaporization. When the bromine and iodine are converted into the vapors, because here the bromine it is present in the liquid state and the iodine it is present in the solid state. Now if we just heat both, what amount of heat of vaporization they required to be changes into the vapors, that is called as the heat of vaporization. So this was all about today's lecture, and that was basically the oxidizing power of the halogens we have. I hope you guys understand, and if you have any queries you may ask me about that in the comment section. And the next topic that we will discuss it is the compounds of halogens, that how what type of compounds the halogens can make by combining with the metals or non-metals or with the hydrogen. So for that time you guys keep learning and have a good day.